Hello, everyone. My name is Namu Gamatha, and my AI project is called Farm Together. Farm Together is going to look at mainly seed sorting. So exportation covers approximately 15% of Uganda's GDP, and among the things we export, like coffee and very many seed-like materials. So for us to ensure that we maximize our revenue that can come from exportation, we ought to ensure that our quality is up to standard and our seeds can be able to fairly compete on the world market. So if we produce or have a bit of low quality seeds in the things we export, we will not be able to fairly compete on the world market, and thus we need to improve the standards of the seeds we export. So how is AI going to solve that? So artificial intelligence allows computers to learn and adopt human-like understanding of things. So the model, which we're going to develop, will tell the difference between the seeds that are fit for exportation and those that are not fit for exportation right before they are exported. So what type of data will be used? The data going to be used is mainly in form of images. So this model will be able to, the images will be captured of the seeds to be exported, and it will differentiate between the two seeds by color, by shape, by size. It will be trained to differentiate between a bad seed and a good seed to make sure everything we export is up to standard. So we have supervised and unsupervised learning. Supervised learning is defined by the use of labeled data sets to train algorithms to classify data. So what is a labeled data set? A labeled data set is data that has been already identified. It's already known. So this algorithm will train the model that we're building to learn the labeled data and make predictions. For example, it's going to train this model to tell the difference between the good seeds and the bad seeds. So this data will be classified. That's what they mean by labeled data. It has already been identified. We know there are bad seeds and there are good seeds. Bad seeds will have this kind of shape, and the good seeds will have this kind of shape. The bad seeds will have this kind of color, and the good seeds will have this kind of color. So this model is trained to differentiate between the two, so that when it sees a good seed, let's say a good seed is brown, it will identify that as a good seed. If it sees something on the contrary, let's say green, it will identify it as a bad seed. So unsupervised learning. Unsupervised learning, on the other hand, is the use of artificial intelligence to identify patterns in data sets containing data points that are neither classified nor labeled. So here we do not have classified, or we do not have labeled data. You have a bunch of seeds, and this algorithm, this model, sets to differentiate, or it will group things according to similarities. It will group the red seeds together, the green seeds together, and then it will identify the patterns and the groups. So, well, the technique in supervised learning. Supervised learning, we have classification. Under classification, the output is categorized. So this, as we said before, the algorithm will teach the model to accept only what should be accepted according to the rules and regulations. If we train this model to only accept green seeds or only accept the brown ones, so anything other than that, it will reject. So that's the classification technique in supervised learning. And then we also have the regression technique. That regression technique deals with output that changes, where a variable depends on another. So the change in one will lead to a change in another. So this algorithm will pick this trend, and we know once this changes, this is supposed to change. So it will pick up that prediction and we'll be able to predict exactly what will happen. If A does this, then B ought to change like that. Then under unsupervised learning, we have clustering. Clustering, remember unsupervised learning, we're dealing with unlabeled data. So grouping items according to clustering, we're going to group items according to similarities. So it will look at a bunch of seeds and it will group them according to appearance or according to their color, according to their shape. They will all be grouped. And once they are grouped, they are going to be backtraced to the origin. And then we have the anomaly detection. So we have a bunch of seeds and we will be able to pick out the seeds that do not resemble the others. So it's going to identify those data points that differ from the rest of the data set. Why does this have this, yet the rest have that? So that's what some of the techniques in unsupervised learning. So what challenges will probably be faced in this project? So there is need for appropriate hardware to run this model. This model cannot run just like that. It will need hardware that will take those pictures and be able to, put them out there for recognition. And this model requires extensive knowledge of the seed appearance. You're supposed to exhaust every form in which this seed can appear so that we do not miss out or let any quality of, let down any seeds that would have been quantified as good quality. And also we have to identify, that's what we're saying, identifying and widening our data set. There are very many different types of seeds. And if we train our algorithm only to accept one, it will be a bit of a challenge because things keep modifying. There can be use of fertilizer that can change the color of the seeds. And then there is also bias. Yes, the model may be biased because of the data that is originally entered into it. So how do we solve these problems? We have to, first of all, acquire the appropriate hardware in which this model is supposed to run. How? We're supposed to look for hardware in which to embed. Is it a phone? Is it a camera? Something that will be able to capture those images of the seeds for them to be processed as bad and good. And then we also have to gather a diverse data set. So our data set is supposed to be able to we are supposed to exhaust every possible seed and its appearance. And then we're also supposed to follow the rules and regulations needed for the quantity assurance. If according to our laws, it tells us the quality should be up to this, and these seeds too should weigh this, so we should follow all those quantities and regulations needed. So we are going to talk about accuracy, precision, recall, and Formula One score. So what is accuracy? Accuracy refers to the evaluation that checks if our model predictions are true or close to true. It's a fraction that predicts it's the fraction of predictions our model got right. So what bit of the prediction did our model actually get right? So that's the true positives plus the true negatives out of the total number of positives. So a true positive is something that is true and the algorithm or the model actually got it as true. And then a true negative is something that is negative and our model was able to identify it as a negative out of the total number of predictions made. So that's accuracy. What's precision? Precision is a ratio of correctly quantified positive samples to the retrieved samples. So the quality of the positive predictions made. We make predictions and then how many are actually true positives? How many samples did the model gets right when they actually write out of the total samples, the total positive samples. And then we have recall. Recall is a measure of models. It's a measure of the model's ability to detect the positive samples. So the higher the recall, the higher the number of positive samples. How were you able? It's like recalling. It's we are measuring the ability to detect the positive samples. Yes, so that it's a ratio between the positive samples correctly classified as positive to the total numbers of positive samples. Then F1 score combines precision and recall to classify it into a single matrix. So it measures the model's accuracy on a data set. So what kind of evaluation metrics am I choosing to do? I chose accuracy because it evaluates the model's predictions. Yes, that's why I've decided to go with accuracy and precision. Precision is the degree of accuracy. You can't, you will be accurate, but you need something to back that up. So it's a measure of the degree of how accurate are your predictions. So if you're getting true positives, so it will get the difference, the rate of the true positives and the true negatives. So that's why I chose the evaluation matrix. And then these are some of the references. So we have the AI helping the farmers, and then evaluation matrix, quality control, supervised and unsupervised learning, and very many others. Um, Thank you so much and have a beautiful night.